Hi everybody. This video is about the Rational Zeros Theorem. This is an important theorem in the study of polynomials, and it's one you really have to be able to read to understand. So, in the Stitt-Ziegler version 3 textbook, the Rational Zeros Theorem is stated as, suppose that you have a polynomial, and we'll talk about the notation in a minute. The degree is n, so that's the highest exponent, and the coefficients, so from the constant term all the way up to the leading coefficient, these are going to be integers. So it says if r is a rational zero of the function, so of the function f, so let's pause right there for a moment. If r is a zero of the polynomial, so that means if you take the polynomial f and you plug in the value r, you get 0. Okay, that's what it means to be a zero. All right, then r is of the form plus or minus p over q. Now, this is kind of an awkward statement, but again, this is why it's important to learn how to read these sort of theorems. So if r is a rational zero, so that means that r is a rational number. Well, the rational numbers are the fractions. So that means you can write r as a fraction of whole numbers. We'll say p divided by q. And we don't know if it's plus or minus, so for emphasis, they say, well, it's either positive or negative, but we're not sure. Okay, so if r is a rational zero of the polynomial, then r is of the form plus or minus p over q, where p is a factor of the constant term. So let's talk about this for a moment. P is a factor of the constant term a naught, is the way you say that out loud. So the number at the end, the constant, P is a factor of the constant. Okay. So what that means is the numerator of this fraction has to be a factor of the constant term. And then the theorem goes on to say q is a factor of the leading coefficient, a with the subscript n, which we read as just an. So q is a factor of the leading coefficient, an. So the leading coefficient, that's the first coefficient, it's the coefficient of the highest degree term. The number q has to be a factor of this leading coefficient. So if you put this all together, the Rational Zeros Theorem says, it actually says something pretty simple. So if you want a rational number that's a zero of your polynomial, you should look for fractions where the numerator is a factor of the constant and the denominator is a factor of the leading coefficient. And that's it. Now, I know there's a lot of symbols here, but this actually says something pretty simple in practice. So I'm going to clear the screen and then show you a practice problem. So here's a very standard type of problem when you're working with polynomials. Now, we're not actually going to find the zeros in this video. That would take a while. But what we're going to do is, again, something pretty common in a pre-calc class, is we're going to list the possible rational zeros. Now the word possible here is actually kind of unusual. A number is either a zero or it's not. There's really no possibility about it. But if we were going to check for rational zeros, these are the numbers that are on our list. So remember the theorem. If you have a rational number that's a zero of your polynomial, then it's of the form p over q. Now, the numerator, that is the letter p, you have to be a factor of the constant term. So the factors of 8 are 1, 2, 4, and 8. Now, the number q has to be a factor of the leading coefficient, which is 15. The factors of 15 are 1, 3, 5, and 15. So, if you want to have a short list of rational numbers that might be zeros of your function, they're the numbers of the form p over q. These factors, the factors of 8, over these factors, the factors of 15. Now, just for students in my class, this is a perfectly fine way to list all of the zeros. I'll go ahead and list out all of them one by one, just so you'll see, but what I have boxed in is fine for my class. So the possible rational zeros, we have 1 divided by 1, that's 1. 1 divided by 3, that's a third. 1 divided by 5, 1 divided by 15. Now let's move on to 2. 2 divided by 1 is 2. 2 divided by 3, 2 divided by 5, 2 divided by 15. Now we go on to 4. 4 divided by 1, 4 divided by 3, 4 divided by 5, 4 divided by 15. And now move on to 8. 8 divided by 1, 8 divided by 3, 8 divided by 5, and 8 divided by 15. Unfortunately, none of these fractions reduced. A lot of times in these sort of problems, some of the fractions will reduce, and that will decrease the number of possibilities that you have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. But remember, plus or minus each one, so we have 32 candidate rational numbers that could be zeros of this function. Now, that's still a whole lot of numbers. There are some other theorems that will help us out to maybe narrow down this list, but this is at least a starting place. So, long story short, if you're looking for rational zeros of a polynomial, start with this list, and this list is formed by plus or minus p over q, where p is a factor of the constant and q is a factor of the leading coefficient. So, that's the Rational Zeros Theorem. Hope this helped.